Here we want to talk about some basic graph properties for the equations. So the first thing is we want to graphing the equations by plotting points. So this is the one way to sketch the graph of equations. We just give some sample points, then connect the sample points to form the graph, right? So for example, we use example to illustrate this idea. So if we have y equals -3x plus 7. So we want to plot in the points, sample points, then connect the points using the straight line, then to form the graph. So we can make a table. The first column is the x coordinate we want to choose, and the second column is the y values. If you plug in the equation, what is the y values for this equation? Okay. And then we have the point corresponding to the point, the sample point we are picking. For example, if we have -1, 0, and 1, if we choose these 3 points, right? If you plug in -1, so y equals what? 10. If you plug in 0, you have y equals 7. So if you plug in 1, then y equals 4. So this point is -1, 10 point, right? And this is the 0, 7 point, and this is the 1, 4 point. Okay, you can have more points to make the graph more accurate, but here I just give you this example, right? Give you an idea. So -1 is here, right? The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's here. So this point would be here, -1, 10. 0, 7. 1, 2, 3, 4, 5, 6, 7. 0, 7 is here. And 1, 4. 1 and 4. 1, 2, 3, 4 is here. If you connect, so this is actually a straight line. Right. If you draw the points correctly, it would be a straight line. Okay. So, but this is not convenient, right? You need to find many sample points, right, to plot in the sample points. A next property for the graph, which is called intercepts. What are the intercepts? Intercepts are the points where the graph intersects or touches the x or y axis. Okay, that is the points where the graph intersects or touches the x or y axis. So it's actually have two kinds of intercepts. One is called the x-intercept. X-intercepts, which is the points where the graph intersects x-axis. And the second intercept is the y-intercept. These are the points where the graph intersects the y-coordinate, a y-axis. So if you have this graph, for example, this is the example. We have this graph. So here is 2, here is -2. Okay. Then x-intercept. X-intercept, there's no intersection, right, on the x-axis, so there's no x-intercept. The y-intercept, we actually have 2 points. One is this point, right? This is the, what's this point? This is not, it's the point is the 0, 2 point, right? Because x is always 0, because it's on the y-axis. And this point is 0, -2 points. So you have two intersects, y-intersect point. So sometimes some problem, so here is some confusion that some problem will say, okay, y-intercept is 2 and -2. That's okay. So it depends on the problem. Some problems say, okay, y-intercept should be the coordinates of each point, right? Some problem says, okay, y-intercept should be the y-coordinate of each point. So both are correct, but it depends on the problem. So the next question is, since we can identify, if we know the graph, right, you can identify the x-intercept and y-intercept directly from the graph. So, but what should we do? How to find the intercepts without knowing the graph? Okay, so from, if we have this one, right? So this is the y-intercept, and this is the x-intercept, and this is the x-intercept, right? So we notice that the y-intercept, y should be satisfied this equation, right? These points are on the curve, so it should satisfy this equation, this function. So if you have 0 here, so this point must have 0 x coordinate, and this is the y. And this is the x1, for example, and the y coordinate must be 0, and this is x2, the y coordinate must be 0, right? So we notice that the x-intercept always have 0 y coordinate. The y-intercept always have 0 x coordinate. So this one gives you an idea how to find the intercepts. So first, let's look at to find x-intercept. How to find the x-intercept? Very easy, because x-intercept y always be 0, right? So we just set y equals 0 in the equation. And solve for x. So similarly, to find y-intercept, with just y-intercept, we say the x coordinate always be 0, so we just set x to be 0. Then solve for y. Okay, so now let's look at this example. So we want to find the x-intercept and the y-intercept of the graph of y equals -x squared minus 5x. Okay, we don't want to know so far we don't know how to graph this quadratic function, right? We don't know how to graph it. Of course, you can just take some sample points and sketch the graph. But it will not give you a very accurate, right, accurate graph. So we can use this algebra method to find the x-intercept. So we set y equals 0, because all the x-intercept y coordinate must be 0, so we set y equals 0. So we have 0 equals -x squared minus 5x. Okay, let's solve it, right? So this one would be, let's multiply by -1. We want to make everything to be positive, right? Equals 0. So here, you cannot divide by x, right? Remember that? If you divide x, you will lose the solution. We factor out x equals that, equals 0. So this one is x equals 0 and x equals -5. So this is the x-intercept. Okay, so sometimes some problem will say, okay, x-intercepts, you want to represent x-intercept in the point form. So it would be 0, 0 point and -5, 0 point. So this equation have two x-intercepts. Y-intercept, we just needed to set x to be 0 in the equation. So it would be y equals -0 squared plus -5 times 0, which is equal to 0. So you have the y-intercept, which is 0, 0. Okay, so the graph, if you can draw the graph, if you sketch the graph, you will notice it would be looks like this one. Okay, so this is the origin, is the x-intercept is also the y-intercept, and you have -5, 0. This is the x-intercept. The next property about the graph is the symmetry. We have three kinds of symmetry. The first one is called x-axis symmetry. So let's look at the graph. X-axis symmetry, that means if you fold the graph along the x-axis, the two curves will coincide. The curve will coincide. This is called, so my mathematically says, okay, if you have a point xy on this plot, if it's x-axis symmetry, there must be, if you draw a vertical line, this point must be negative x and a negative y. Okay. So in other words, if this represent so these 2 points are, both points are on the graph, so that means both points satisfy the equations. So in other words, if you want to know, if you just replace y with -y to see if you have the same equation. If you have the same equation, that means it must be x-axis symmetry. The second symmetry, which is the y-axis symmetry. The y-axis symmetry means if you fold the graph along the y-axis, the curve will coincide. So mathematically, it means if you have a point, xy point, and if you fold it, and this point is still on the graph, and this point would be -x and -y. Okay. And the third symmetry, sorry, I made a mistake. If you fold it along the y, so y didn't change, -x and y would be on the graph also. 3, which is called the origin symmetry. It means if you fold along the x-axis, then fold along the y-axis, then the curve will coincide. Or if you fold y-axis along the y-axis and then x-axis, the curve will coincide. So the graph will look like this one. Okay. If you have an x point, xy point here, if you draw a dashed line through the origin and continue their intersection point here, this point must be negative x and negative y. So in other words, if xy is on the graph, then negative x, negative y is also on the graph. So this is called the origin symmetry. So how to test? We're using the idea from the graph. Test for symmetry. How to test? First one, if you replace y with negative y and get the same equation, we don't change x. So that means xy is on the graph, then x negative y is also on the graph. X negative y on the graph. So this would be x-axis symmetry. So then it's symmetric with respect to x-axis. So this is x-axis symmetry. 2. If you replace x with negative x in the equation and get the same sum, get the same equation, then this graph must be symmetric with respect to the y-axis. With respect to y-axis. Right? So that we don't change y. So that means xy is on the graph, then negative xy is also on the graph. xy on the graph, then negative xy on the graph. So this y-axis symmetry. Third one, if you replace x with negative x and y with negative y, and get the same equation, then it's symmetric with respect to the origin. So that means xy is on the graph, then negative x, negative y would be also on the graph, right? Which is the origin symmetry. So now let's look at this. We want to check the symmetry. Symmetry for the function y equals x over x squared plus 1. We don't know the graph, right? We cannot identify directly, but we can still use the algebra way to find the symmetry. So the first thing, let's look at the x-axis symmetry. What we should do, we just replace y with negative y. if we have the same equation as the original one? No, because it gives you y equals negative x over x squared plus 1. So this is not the same equation, so there's no x symmetry. What about y-axis symmetry? We replace x with negative x, so y equals negative x squared plus 1. So we have negative x. This is x squared plus 1. Not the same equation as the original one. So there's no y-axis symmetry. What about the origin symmetry? We replace x with negative x and y with negative y. Let's look at this one is y equals x with times negative 1 on both sides, so that it becomes positive x, and this is x squared plus 1. Yes, we have so it's the origin symmetry. This graph is symmetric with respect to the origin. Okay. So now let's look at another special equation for a circle. Okay. What is a circle? Circle is a collection of the points which have the same distance from the fixed point. Right? If this is the fixed point, HK. Circle is the collection of all points have the same distance. Same distance. It's not good. I didn't draw very well. Okay. So all the points have the same distance. This distance is called the radius, right? It's called the radius. Every point have the same distance, r. So if we form an equation, so the distance between these 2 points would be r equals square root x minus x, so x minus h, plus y coordinate minus y coordinate, y minus k squared. So if we square on both sides, so you have x minus h squared plus y minus k squared equals r squared. So that is the equation for a circle. Here, h and x is called the center. Okay, center is h and k. Radius is r. Right? So h, k, and r are given, then x, y are the points, right? So this is the equation for this circle. There is a very special, let's look at one remark, very special circle, which is r equals 1, and the center, h and k equals 0, 0. Center is at origin. This is this one. Here's 1, 1, negative 1, negative 1. So this is called unit circle. Unit circle. So now let's look at one example, and this is called the standard form of the circle. Okay, circle equation, standard form. So now let's look at this example. We know that the point 1, negative 2 lies on a circle whose center is at negative 3, negative 5. We want to find the standard form of the equation of the circle. Okay, so the first thing, we know this 1, 2, negative 2 point is on the circle and the center, so we can find the distance, right, between these 2 points. That will give you the radius. So the radius is equal to the square root of the distance between two. So x minus x coordinate, so 1 minus negative 3 square plus negative 2 minus negative 5 square. Okay. So I always would like to use the parentheses. Okay, that will not always, that will eliminate some silly mistakes. Many students will say, okay, 1 minus 3. It will confuse yourself. It's actually minus negative 6 plus 3, right? So it would be 16 plus 9, so this is 25, square root 25 equals 5. So r equals 5. And we know the center, we know the radius, then we can always use this standard form. This is hk at the center, and r is the radius. So with this would be x minus the center. Center is minus negative 3, so it's plus minus. Let's write one more step. Plus y minus the center, negative 5 square equals 5 square. So let's rewrite this is x plus 3 square plus y plus 5 square equals 25. So this is your equation. So now let's look at another example. We want to find the standard form of the circle whose endpoints of a diameter are negative 4, 1, and 2, negative 7. Okay, so this is a circle, right? Diameter is the line through the center. Okay, so this is so these 2 points, one point is negative 4, and 1, the other point is 2 and the negative 7. Okay, so we can calculate. The first thing is the diameter is the double size of the radius, right? So if we can compute the distance between these 2 points, then divide by 2, it would be the diameter and the radius, right? So to find the standard form of circle, we need 2 things. We needed to know the center, hk. We also needed to know the radius, right? So the radius is the first thing. Let's find the distance between these 2 points. Okay, we use d, which is negative 4 minus 2 square plus 1 minus negative 7 square. If you calculate, it would be 100. So square root 100 equals 10. So this is the distance. So here to here is 10. The diameter is 10. So the radius is 1/2 of the diameter, which is 5. And the center, we notice that the center hk, this center, which is actually the middle point of these 2 points, right? So this middle point m, this is we denoted by m. The m is equal to the middle point of these 2 points. So the middle point is the average of the x coordinate and the average of the y coordinate plus, okay? So it becomes negative 1 and negative 3. So this is the center. Then we have the center, we have the radius, so we can have, okay, which is x minus negative 1 square plus y minus negative 3 square equals, so this is the h and k, that's right. Let's just use another color. So this is h, this is k, right? This is h, this is k, equals r squared, right? R squared is 5 squared. So let's rewrite. This one would be x plus 1 squared plus y plus 3 squared equals 25. So this is your solution.